Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 88. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have a little more solving space. So my equation is 8 to the power of x is equal to 88. Now I'm first going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 88. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. In this case, I have log 8 to the power of x, and I can move x to the front, so I get x times log 8 is equal to log 88. And the reason this property is so useful is because before, x was an exponent. And for our equation, if x is 1, I get 8. If x is 2, I get 64. And if x is 3, I get 64 times 8, which is 512. And we want to find what value of x results in 88, which is somewhere in between 2 and 3, but we don't know exactly where because it's going to be a decimal. So we can't really find the exact value as x when x is in exponent form. So this is why we can make it into a real term using this property, and now it's much simpler to solve for it. So now I have x times log 8 is equal to log 88. And I want to isolate x because that's what I'm solving for, so I'm going to get rid of this log 8 by dividing both sides by log 8. So now these two cancel out, and I get x is equal to log 88 over log 8. Now log 88, I can rewrite this as log of 8 times 11. So I have log of 8 times 11 over log 8. And now another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So log of 8 times 11 is going to equal log of 8 plus log of 11, and I have this over log of 8. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, which is a simple fraction property. So log 8 plus log 11 over log 8, I can write that as log 8 over log 8 plus log 11 over log 8. Now, log 8 and log 8 cancel out to get 1. So I get 1 plus log 11 over log 8. So now all that's left is to plug in the actual values of log 11 and log 8 and solve. So log 11 is equal to approximately 1.04, and log 8 is equal to approximately 0.90. So I get x is equal to 1 plus 1.04 over 0.90, which is equal to 1 plus 1.16, meaning x is equal to 2.16. So this is my answer. Alright, so in this video, I'm going to be solving the equation 25 to the power of x minus 5 to the power of x is equal to 20. So to solve this equation, I'm going to first start by subtracting 20 on both sides. So then these two cancel out, and I get 25 to the power of x minus 5 to the power of x minus 20 is equal to 0. Now 25 to the power of x, I can rewrite this as 5 squared to the power of x. So I have this minus 5 to the power of x minus 20 is equal to 0. And now from here, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And a to the power of m times n, I can rewrite as a to the power of n times m. So if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m should equal a to the power of n to the power of m. So 5 to the power of 2 to the power of x is going to equal 5 to the power of x to the power of 2. Now I have this minus 5 to the power of x minus 20 is equal to 0. And now I'm going to let 5 to the power of x is equal to y, so I get y squared minus y minus 20 is equal to 0. Now, to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 20. So I get y equals negative 1 plus or minus the square root of b squared, so negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 20, all over 2a, so 2 times 1. And this is equal to 1 plus or minus the square root of 1 plus 80 over 2, which is equal to 1 plus or minus the square root of 81 over 2. And the square root of 81 is equal to 9. So I get y is equal to 1 plus or minus 9 over 2. Now this gives me two solutions. I get y equals 1 plus 9 over 2 and y equals 1 minus 9 over 2. So 1 plus 9 is 10, and 10 divided by 2 is 5, so I get y equals 5 as one solution, and 1 minus 9 is negative 8. Negative 8 over 2 is negative 4, so y equals negative 4 is another solution. Now from here, remember how we let 5 to the power of x equal to y. So this means I get two solutions. 5 to the power of x is equal to 5, and 5 to the power of x is equal to negative 4. So let's look at this equation over here. 5 to the power of x equals negative 4. Well, we can't take the power of a positive number and turn it into a negative number, meaning this equation has no solution. And for 5 to the power of x equals 5, to solve this, what most people do is, for other exponential equations, we would have to take the log and do a bunch of other stuff. But as over here, we could just see 5 to the power of 1 is going to equal 5, because anything to the power of 1 is itself. So this is my solution.